Hey, buddies. Okay, we got this beauty right here, which involves this beauty right here, which looks overwhelming. I know it does, but I'm going to show you guys something. If you just do what I say right here, I'm going to show you a real simple way to do this that's going to make it so that it's not too bad at all. So, in each of these problems, problem number one, problem number two, three, four, don't worry, there's a backside. In each one of these problems, you need to show four things: the pH, the pOH, the hydronium ion concentration, and the hydroxide concentration. So one of them, the problem's going to tell you what it is. And you need to use this to find the other three. Want to see? I bet you do. Okay, problem number one. A 1/10 molar solution of hydrochloric acid. Well, hydrochloric acid is a strong acid. I know it's a strong acid because I have a list of strong acids down here, and hydrochloric acid is on it. Hydrochloric acid is a strong acid. And the concentration of a strong acid is equal to the concentration of hydronium in the acid. That's because every single acid molecule in there is going to donate a proton to a water molecule. So however many acid molecules there are, that's how many hydronium ions there's going to be. So this is the concentration of the strong acid. So the concentration of the strong acid is equal to the concentration of hydronium. And the concentration of the strong acid is 0.1 molar. So the concentration of hydronium is 0.1 molar. So boom, we nailed this one right here. Because the concentration of hydrogen ions, that means the same thing as the concentration of hydronium. So we got one of the four, yeah? Now we have to leverage this. We have to use this information to figure out the other three. So here's how we're going to do that. Here's all four of the things. 1, 2, 3, 4. This is the one we already have. We can use one of these two formulas to find this. But which formula are we going to use? This top one or this bottom one? That's right. We're going to use the top one because we're going from hydronium to pH. And see the arrows? They're pointing that way. That's the way we want to go. So we're going to use this formula right here. So it says that pH is equal to the opposite of the log of the hydronium ion concentration. And the hydronium ion concentration is 1/10 molar. So all we have to do is get out our calculator right here, and we have to say the opposite. Here, let me move this up here so you guys can see what buttons I'm going to push. I'm going to push this opposite button right here, the opposite, and then I'm going to push the log button, which is right here. See that sucker? Opposite of the log of 1/10. And then I have to close the parentheses. It opened it for me, so I have to close the parentheses. Boom. And push enter. And it equals 1. So the pH is 1. Yeah, nice. Okay, sweet. So we just got the pH. Now we still have to get these two down here. So we could go from here to here, and then from here to here, or we could go from here to here, and then from here to here. It doesn't matter. You can do whatever you want. It doesn't even matter. Let's get this one first, right here. Sound good? The hydroxide concentration. So we're going to go from here to here. This formula will work in either direction. So here's how it works. the hydronium concentration, which is 1/10 molar, times the hydroxide concentration, which we don't know what it is equal to 10 to the negative 14. Yeah. So we're just going to divide, this is just algebra, we're just going to divide both sides by 1/10 and get rid of that. And then the hydroxide concentration is going to be equal to 10 to the negative 14 divided by 1/10. And I know we're dealing with weird numbers in here, you guys, but it's all good. Just trust in the process. It's going to be cool. Here's how you put 10 to the negative 14 into this calculator. All we're going to do is we're going to do 10, and then we're going to use this caret button right here, and we're going to say to the negative 14. Yeah. And then we're going to divide it by 1. Boom. And we're going to get 1 times 10 to the negative 14. So that's the concentration of the hydroxide. Okay, sweet. Then we've got this. Now all we have to do is get this beauty right here. So we could either go from here and use this formula and go to this, or we can go from here and use this formula and go to this. I'm going to use this one because it looks nice. So the pH, which is 1, plus the pOH, which we don't know, is equal to 14. So we just have to do a little algebra right here. We're going to subtract 1 from both sides. We're going to say that the pOH is equal to 14 minus 1. So the pOH is equal to 13. Yeah? Beautiful. Okay, nice. Now we're going to do this one down here. The pH of a solution of hydrochloric acid is 1.530. So remember, there's always going to be 4 that we need, and one of them is always going to be given to us. So which one did they give us here? Well, it looks like they gave us the pH. They said straight up that the pH is 1.530. pH doesn't have any units. Sweet. So now that we know the pH is 1.530, we can get this with this formula, and we can get this with this formula down here. So let's do that. Well, this one, we already know how to use this beauty because we did it up here. To find the pOH, we're just going to do this. We're going to say that the pH plus the pOH is equal to 14, and the pH is 1.530 plus the pOH equals 14. So we're just going to subtract 1.530 from 14. We're just going to go 14 minus 1.530, and that's going to be 12.47. So the pOH is equal to 12.47. Nice. Okay, sweet. Here, I'm going to get rid of this thing. Boom. Okay, so we got the pH, we got the pOH. Now let's get maybe this hydronium ion concentration over here. So we're going to use this formula right here. So the hydronium ion concentration is equal to 10 to the power of the opposite of the pH. Okay? So the hydronium ion concentration is going to be equal to, get my calculator here, and I'm going to put in 10, and then I'm going to push the to the button right here. This is the to the button. 10 to the negative, and what was the pH? I can't remember. Oh yeah, it was 1.530. 1.530, like that. Enter. So the hydronium ion concentration is 0.0295 molar. Yes? Which is the same thing as 2.95 times 10 to the negative 1, 2 molar. Either one's fine. This is preferred, I guess, because here you can miss zeros and stuff and get all weird, but here it's nice. Yeah? Okay, so we got 1, 2, 3 of them. Which one do we still need to get? We still need to get the hydroxide ion concentration. So how about we use this one right here? Should we use that one or should we use a different one? Let's use this one right here. It's nice. So the hydroxide ion concentration is equal to 10 to the negative POH. 10 to the negative POH. So the hydroxide ion concentration is equal to 10 to the negative 12.47, which is equal to, let's try it. Ready? Let's push 10 and then the to the button right here. 10 to the negative 12.47, and that's equal to 3.39 times 10 to the negative 13 molar. Yeah, and that is the hydroxide ion concentration. Yeah. Booyah! You guys do number 3, and then when you're done with number 3, do number 4, and then do number 5 and number 6 and number 7 and number 8 and number 9. All right, buddies. Enjoy yourselves.